In this section, we're going to be looking at making regular deposits or regular payments. So this is a little different from what we've done in the past. In the past, we made one deposit, usually some big amount, and then we let it sit in an account and accrue interest. Now, while that's useful, the way that most people are going to operate is instead of putting one giant amount in, they're going to put a smaller amount in more regularly. So let's look at a scenario where we deposit $60 at the end of each month for 15 months. And then we have our usual information about what's the interest rate and how often is it compounded. So again, this is where it's a little bit different because we are saying we have $60 regular deposits. So we're going to start off by filling out a table, kind of like what we did for the one big investment, and then we're going to translate that into something that's a template that we can use. But I think that starting off with an example like this helps us get a better sense of what exactly is going on. So I'm going to pull up Excel here and maybe remind us of a few little pieces. So I was using kind of a version of the old one that we had. So we're doing $60 deposits at the end of each month. So we could say, okay, this is equal to 60, or we could just do, $60 is fine. This amount is going to be the same for all of them. So that part's pretty easy. The beginning balance, well, if this is, right, if we're thinking the beginning of January, I had $0, and therefore I can't really earn any interest on that balance. So this is also going to be $0. And so at the end of the day, I just made my deposit. So January 31st, I just have the $60 that I put in, but usually there's going to be some sort of beginning balance and interest. So really how we should be looking at this is thinking draggable formulas. So what is something that's going to apply to all the other months? Well, I will have that deposit, but let's think about it. The ending balance for a month would be whatever your starting balance was, plus the interest that you gained on that, plus your deposit. And again, because the deposit's being made at the end of the month, it's not accruing any interest that month. It will absolutely accrue interest the next month. So, right, for this first value, it's just the $60 we deposited at the end of the month. And if we drag this down, we're just going to get 60. We haven't filled in these other values yet. So the beginning balance, well, this part is going to be pretty straightforward as well. It's just whatever the ending balance was for the previous line in the ledger. So we say, okay, this is equal to, we go to ending balance here. And again, this thing, if we just drag it, then we start to see a few changes. We say, well, okay, right now we've only accounted for deposits. So this is increasing by $60 each month, right? At least at the beginning. And because the deposits are made at the end, we see that the ending balance is always $60 more than what we started with. Now this is going to change a little bit though, because of course we're accruing interest, and we're just doing this for a few months. So I'm not going to go through the entire 15-month thing. Really, the goal of this was to get a sense of like, hey, what's happening with this? So what we know is that we're earning interest throughout this month on whatever the balance was that we started with. So even the very first month, we could write it as a formula instead of just saying $0. We know it's going to be zero because we didn't have any money, but let's see how that would actually work. So we have, if we go back to our problem, we have a 4.2% APR, and it's going to be compounded monthly. So we've seen something like this before. So if we're just looking at the interest, well, we take that 4.2%, we call it 0.042. Because we're compounding monthly, right, we're not getting 4.2% every month. We're getting 1/12 of that, right? If this was weekly or quarterly or daily, we would change this to something else. But most of the time we're dealing with monthly, especially when it comes to financial things like interest accruing and what have you. So we're going to say, okay, this is the amount, the percent of interest that I am gaining on my beginning balance. But if I just hit enter here, right, it's going to give me a dollar amount because of how I had stated it before. I could certainly change this thing and say, well, what if I, instead of currency, just wanted to see this as a number, and we could bump this thing out to a couple decimal places and say, okay, so I guess I'm getting 0.35% at this moment. So this is just the percent. But we don't really want that, right? We want to say, okay, I'm getting that percentage of my beginning balance. And that's what I'll have at the end of the month. So that's why we don't see it show up until we look at the ending balance. Okay, because I don't want to see this as a decimal, really, just as a percentage, I'm going to highlight all this stuff. And, well, I drag it and highlight it, and I'm going to change this back to a number of dollars. And in the first case, right, we see that there's nothing there. It just gives us a dash. And we can highlight one of these, right? I like to do this, just make sure that everything is looking good. So it's our value, 0.042 divided by 12. So the monthly interest rate, essentially, times whatever I started with. And this amount goes up every single month because we're seeing that, right, our beginning balance is increasing. Therefore, the interest that we earn on that balance should also be increasing. Now, the deposits, we said regular. So when we look at this ending balance, right now it only goes to the nearest dollar. So I think it might be worth seeing this maybe to a couple more decimal places and saying, let's see if we, instead of going to 0 decimal places, maybe we go to 2, right? Dollars and cents, I think, is a worthwhile thing to take a look at. So we're picking up more interest as we go. Even though our deposits are the same, we're getting more and more interest over time because we're making interest on all of the previous deposits that have been made up until that point. So at the end of, all right, in this case, just at the end of 5 months, we have deposited $300, right? We did 5 months of $60. So this total, if we added those up, would be $300. We have made a total of $2.11. We could find that either by adding these or by saying, what's the difference between my ending balance and how much I personally deposited? And that would be the interest that we would gain. So really, this is, again, just trying to get us to think about how this would look. It's very similar to the exponential stuff we've been doing, but with a small change. So let's take a look at another example. And one thing that I wanted to do along with this example is maybe provide some of the functions that I introduced last time, just in case there's something we need to solve for in the future. We are absolutely going to be solving for payment values. We have already solved for present values, future values. You can solve for the rate. Basically, that's saying what interest rate do I need in order to reach some sort of goal? Or if this is the scenario that played out, what was the interest rate, that kind of thing. All of the Excel variables are listed down here. Like I said, I'm going to give you a template for all of these, but it's still worthwhile to maybe look at some of those equations and see what I had put in just to get a sense of them. Maybe the one thing that's important is, in general, we're assuming, so way at the bottom here it says, we'll assume that all problems in this chapter have payments at the end of the period. So end of the month, end of the quarter, whatever that might be. So that's how I operated when I made the template. That changes if those deposits happen at the beginning of the month. Okay, so this example, we're saving to buy a house. We're going to deposit $400 at the end of each month for 3 years at an APR of 3.7% compounded monthly, right? So one thing that we know is a lot of these pieces are like what we've seen before. So we could say monthly, right? This is telling us M equals 12. Our regular deposits, this is PMT, the payment amount is 400, right? And again, I'm just kind of using some of the lingo in Excel, even though you've got that already there for you. Our T value is going to be 3, right? T is always measured in years for these examples. And then, of course, our interest rate R is 3.7%. So let's pull up the template. And this one, keep in mind, kind of like the last one, I doubled down. So I put credit cards on here as well. And if we scroll down, there's 2 different versions here. So this is if we are trying to figure out a future value based on regular deposits. And then if we scroll down, we can solve for the payment or solve for the deposit if we know a goal that we want to reach. So in this particular example, we don't have any initial investment. So it is possible we put down $1,000 and then do monthly deposits. We'll see examples like that. But for this one, we don't have that. Our regular deposit amount is $400. Our interest rate is 3.7%. Again, if you're going to type it as a percent, include the percent symbol. Again, this will say 0.04, but if I click on it, I see 0.037 up here. So everything's fine. If you want to see more decimal places, you can do that. compounds per year, 12, that's going to be our usual go-to, but not always. Time in years, that's going to be 3. So we put all the yellow values in. I showed you some of the breakdowns, like what is your interest rate per compound, so per month. Here's what we're getting as far as interest. Total compounds is here, so basically we make 12 deposits a year for 3 years, so 36. So the first thing tells us how much did we pay? How much of this is our money? And that's the $400 per month payments over 36 months. So we put down $14,400, and at the end of the day, the interest, well, I should say the future value is $15,204, and this one, let's see. So this one, sorry, is a small change. It's supposed to say minus what you paid and minus the principal. So that's going to be 804, right? That's just the difference of how much I paid and what the total value is. So this will be 804.86. And let's see, what did we want to know? So what's the future value for this? And so that's our value with the interest added in there. So that's going to be the $15,204.86. Okay, let's suppose we deposit $2,500 into an account and then make some regular deposits. So this is a case where we do have a principal, right, a present value of $2,500. The regular contributions, the regular deposits are going to be 50. The interest rate is 0.03 or 3%. Again, we're compounding monthly. We can leave it there. And how much is in there at the end of 10 years? So again, we're making in total 12 payments a year, 10 for 10 years, so 120 total deposits. That means that we have paid, and this is just talking about the deposits, so not including the principal, although we could certainly factor that in. That wouldn't be an issue. That might be something to consider. So total paid would be the monthly payments of $50. So that is $6,000. Like I said, if we want to include the principal, and I think maybe I'll update the formula to do that. So we could do something along those lines. But I think right, that means we'll kind of have to adjust a couple of these other pieces. So it's an either or, I suppose. So I had put in B4. I think I'm going to undo that one just so it doesn't get too confusing here. Okay, so basically we put in this much. We already had $2,500 in there. We gained $1,860.45 in interest, and then at the end of the day we've got $10,360.45. So here's what I'm going to tell you. The template here is a great tool, but just like I was saying, values like this, we have to be open to the idea of what these things mean. So this total paid, I'm going to leave it as just here's what I put in based on my monthly deposits. But of course, we paid the principal value too. So in total, we would have paid $8,500. So keep that in mind as you're working through. Just because we have the template, I still want us to be thinking about it. All right, so how much is in the account at the end of the 10 years? That's what we were going for. So in this case, it was just the very last item in our template. If we needed the interest, it's right before that. So again, just sort of be flexible in what's the question asking for and what do I need to know.